Now children, today force and motion chapter 8 I am starting for class 9 anxiety foundation level. Today topic is inertial frame and non-inertial frame. Now inertial frame means any frame where the event is occurring that moves with constant velocity or it will be rest. That means in that frame Newton's laws first law is valid. Again I am telling any frame where the physical event is occurring, that event where physical event is occurring means that frame where the frame is at rest or moving with uniform velocity, then we should say it is inertial frame. In inertial frame Newton's all laws are valid. Now non-inertial frame means any frame which is moving with acceleration. Suppose when a bus applying brake or you are moving with accelerated train, then there is a this is called non-inertial frame. In non-inertial frame, we imagine suppose a body A, on this body there is another body B. If A is moves towards east, another pseudo force will act on the second body B opposite direction. So non-inertial frame, when we feel a force that is known as pseudo force, this pseudo force will act opposite to the mother applied force. That means if A moves toward east, then any body B placed on A will move towards west. That means pseudo force always act opposite to the mother applied force. Then again I am repeating, inertial frame means any frame having zero velocity or uniform velocity or rest. Non-inertial frame means any frame which is moving with acceleration. Where pseudo force is applicable? Pseudo force is applicable only in non-inertial frame. Now this is very important to solve some numerical problems in mechanics. After that I am considering component of force. Now children, after a long time I meet you. Suppose a force F is acting making some angle theta with the x-axis. Now you may ask me, this force having two components, you draw perpendicular on x-axis, that is of A and B, and you draw another perpendicular on y-axis, that is C. So in that case we consider two components, one is Fy, another is Fx. That means if a force acting at an angle theta with the x-axis, this force can be taken two component wise if you think that Fx, that is horizontal component. So horizontal component will be horizontal component Fx by F equal to cos theta, or you can write Fx equal to F cos theta. Similarly, Fy equal to F sin theta. That means any force making angle theta with the x-axis having two components. One component is along the x direction, that is horizontal direction, that is F cos theta, and another component that is perpendicular to x-axis, that is along y-axis, that is F sin theta. So we always remember these two components. Very important, these two components. So inertial frame I have told, any frame having rest or with uniform velocity. Non-inertial frame, any frame moving with acceleration and pseudo force will act opposite to the mother applied force. Then component of force, any force making some angle theta with the x-axis. This force having two components, one is along the x-axis, that is Fx. Now Fx by F, you know base by hypotenuse, that is equal to cos theta. So Fx equal to F cos theta. Similarly Fy equal to 90 minus theta. You can write in this way, Fy by F equal to cos 90 minus theta suman sin theta. Now children, Fy equal to getting F sin theta. So today in my class I have told you that two components I am considering. One is F cos theta, that is along the x-axis, and F sin theta, that is a vertical component. After that children, I am considering that is parallelogram law of force addition. Children, you know that force is the vector quantity. So parallelogram law of vector addition, or tell force addition or momentum addition or displacement addition same. Or so, that means whenever any vector is added, you follow the parallelogram. Now I am teaching you how parallelogram law of vector addition. Answer number 3. Suppose O is the point, two forces are acting, one is F1, other is F2. Angle between them is theta. Now children, you may ask me, if F1 and F2 acting on the point O, what is the resultant force? Some students do some mistake. They just adding F1 and F2. No, it is not adding just, or F1 minus F2. Now what is the general formula I am using? You complete the parallelogram. You take the perpendicular, that is in diagonal. OB is the diagonal. OB is the R. That is the resultant force Fr equal to root over F1 square plus F2 square to F1 F2 cos theta. Now I am taking F force vector, but you can take any vector and you apply the same principle. Suppose here is the two momentum, then P1 square P2 square to P1 P2 cos theta. Theta is the angle between the two vectors F1 and F2. Now if theta equal to 0 degree, then resultant force will be numerically F1 plus F2. You know, when a boat is moving along the current of the river, then you consider resultant velocity of the boat plus velocity of the current of water. Now if theta equal to 90 degree, then it is coming Fr equal to root over F1 square plus F2 square. Now if theta equal to 180 degree, then you are getting F minimum, then it is coming F1 minus F2. So maximum resultant F1 plus F2, minimum resultant F1 minus F2. Now this resultant force makes some angle alpha with the F1. Then we get tan alpha equal to, always remember this formula again you will face in class 11. So I should suggest that how can I write F2 sin theta plus F1 plus F2 cos theta. Clear? So direction of the resultant I have obtained. Again I am repeating. Parallelogram law of vector addition is, I am taking only one example with the help of force, but this law is applicable for all vectors. In that case, F1 and F2, two vectors making some angle theta, then students, you are asked what is the resultant. Resultant means you consider another vector force F R whose effect on the system will be same as affected by F1 and F2. Now this resultant Fr equal to root over F1 square plus F2 square plus 2 F1 F2 cos theta. Now theta equal to 0 degree, then cos 0 1, you know, then it is coming F1 square plus F2 square to F1 F2, then F1 plus F2 whole square, the resultant will be maximum F1 plus F2. If theta equal to 180 degree, then their reverse direction they are acting, then minimum resultant will be F1 minus F2. So children, in my class today, after a long day, I am meeting you inertial frame and non-inertial frame, component of force, parallelogram law of force addition. Now this I have done. Now children, very important law, that is I am considering Newton's third law with examples. Now children, Newton's third law, already you know, every action has equal and opposite reaction. Suppose you know A is a body, B is another body. If E is giving action on B, action force, then B giving reaction on A. That is question number 4. Answer 4. That means action reaction acting on two different bodies, they do not cancel. You remember, if A producing action on B, B giving reaction on A. As for example, if you put a book on a table, this book weight acting downward, it is a book and it is a table. Now table give reaction on the book, that is reaction by table, reaction by table. Okay. Similarly, suppose you are with a boat. Suppose you are moving in a boat. You are striking the sword. This, when you are striking the sword, then it is action, and sword will give you the that is reaction. Sword will give reaction to the board, as this reaction having two components, and one component help the board to move. Similarly, rocket, you know rocket, in the case of rocket, fuel is coming out, that is action on air. Then air will give reaction on the rocket, and due to this reaction, rocket will move up. Clear? Suppose a person holding some load on head. Now this load action on head and reaction on this load by head on the load. Similarly, when you are walking by leg, we are giving action on the floor, and floor giving reaction on the leg. This by leg we are giving reaction on the floor, and floor giving reaction on the load. So there are so many examples by which we can say every action has equal and opposite reaction. Children, always remember that action reaction does not act on the same body. As for example, when you are cycling, you can't stop your cycle by pulling your handle backward direction. Or if you put fan in a boat, on the screen, if you apply your gust of wind, boat will not move, because action reaction acting on the same system. Now this is the third law, and third law is very important law for action reaction conception. I have given action. Suppose you write down F A B, or you write down B A. That means force given by A on B equal to minus F A B. Why minus? Because direction of action just opposite to the direction of reaction, but numerical they are equal. Okay, children. Now, from that third law, we are going to derive conservation law of momentum. Children, this third law is very important in the sense we apply conservation law of momentum. In mechanics, when you are appearing for a NEET exam or AIEEE exam, you will see so many numericals in mechanics can be solved with the help of conservation law of momentum. Let us derive this law, conservation law of momentum, and we are deriving conservation law of momentum. Now children, you know, suppose two bodies M1 and M2. We are considering two bodies M1, they are moving on the same track in the same direction. M1 with velocity U1, and that is M2 with velocity U2. Now, if U1 is greater than U2, then what will happen? After certain time they will collide, and after collision, now velocity changed V1 to V1 and V2. Again I am telling, after collision, time of collision T. Again I am telling, we are considering two bodies M1 and M2. They are moving with velocity U1 and M2. They are on the same track. Now certainly M1 will strike M2, and after interaction velocity after collision will change. Velocity of M1 will be V1 and velocity of M2 will be V2, and time of interaction is M1. So now I am considering force on M1 by M2 equal to, what is the force? Velocity change, rate of change of velocity, that is M1, velocity change V1 minus E1 by T. Similarly, force given by M2 and M1, that will minus M2 we are getting m2 v2 minus u2 by t. Now this is the if m1 m2 means force on m1 given by m2 equal to mass of the body and velocity change. You see what is the velocity change? Initially it is v1, finally it is v1. Similarly for the second body, initial is u2, final is v2. So we are getting this. Now we have m1 v1 minus e1 by t equal to minus m2 v2 minus u2 by t. Why minus? Children, minus in the sense the reaction is opposite to the action. So now p cancel. If you take all in one side, you are getting m1 v1 plus m2 v2 equal to m1 u1 plus m2 u2. Proved. Then when Newton's third law, conservation law of momentum is proved, it means if no external force acting on any system, only internal interaction taking place, that means conservation law of momentum is valid. Conservation law of momentum means before interaction and after interaction total momentum will be conserved, reserved. That means conserved, momentum will not change. That means initial momentum of the two bodies before collision, final momentum of the two bodies after collision remains same. Okay children, now this chapter force and motion is very important. So in different class we are taking revision class, we are giving revision to you so that your basic level, foundation level in class like this Roy Sir Roy Physics channel is only for develop your conceptual base so that you can easily appear for any competitive exam in the long run. So children, I am meeting you after so many days, but one by one I am doing so many things. Next class I shall do. Children, if you think that this channel is very helpful to you or you are getting benefit from this channel, then please you subscribe this channel and encourage me to do better video for next class. Thank you.